Hey students, today we are going to see third video, that is elementary signals. First elementary signal we are going to watch is unit impulse function. What are elementary signals? Which is the building block for the construction of different complex signals. Now we can model a large number of physical signals which occur in nature. So they are also called as standard signals or else test signals we can call it as. Now what are unit impulse functions? It is mostly used for the analysis of signals and systems. Unit impulse function, it is also called as Dirac delta function. Dirac is a scientist who invented this impulse function. So it is named as Dirac. Del is used to represent the impulse function. So it is called Dirac delta function. Now we have the equation of unit impulse function. In continuous time, it is represented as integral minus infinity to infinity del of x dx equal to 1. Now this is the function del of s dx equal to 1. Coming to this, now here del of t is a unit impulse signal is equal to the amplitude will be equal to 1 for t equal to 0 and 0 for t not equal to 0. Now here you can see the exact thing. You can represent this in a graph. That is, we are taking x-axis t and y-axis del of t. We are plotting it. For continuous time signal, we will mark using an arrow. Discrete time will plot using a dot. Now, unit impulse signal, it is assumed in a form. If we are assuming this as a pulse form, we can tell that the width of the pulse is 0 and the height is unity. For unity, it is unity. Now, if you're considering a normal impulse signal, the amplitude or height, you can take it as infinity. So, the area under the pulse curve is always unity. Now, this is the thing. Now, considering the next signal, if you are taking the unit step signal and you are building a relation between impulse signal and step signal, what is the relation? Now, if you are differentiating this step signal, you will get this del of t, that is impulse signal, or else if you are integrating this impulse signal, we'll get the step signal. Now, what are the properties of continuous time unit impulse function? Now, continuous time we'll denote it by t, and for discrete you will represent it by n. So the first property is del of t is equal to del of minus t. Now, it is an even function. If t is equal to minus t, then it is an even function. So that's the first property. And the second one is sampling property. Sampling property in the sense, now if you have a continuous time signal and if you want to convert to discrete time signal, or we'll use a property, that is, we'll use a principle, that is sampling. That is, we'll get samples. So now here you can see if you're multiplying x of t, that is x of t, which is the value will be equal to 1 for t equal to 0. So if you're multiplying, you'll get the zeroth value alone. It is x of 0. That is sampling property. Now, third property is shifting property. Now, how we can write the shifting property? In the place of this del of t, we are giving it as del of t minus t0 dt. T minus t0 dt. Now we are shifting it by t0. Now we are delaying by a function of t0. Now if you are doing the same operation, you will get x of t0. That is the shifting property. Now, fourth one is scaling property. Now, what is scaling property? Scaling by a factor of a. Now, if you're the scaling by a factor of a, now we'll get the value as 1 by modulus of a into del of t. Now, product property. Now, x of t into del of t. Del of t is equal to 1 for t equal to 0. Now, if you are multiplying x of t with a function of del of t, normally we'll get the function x of 0. Already we know. Now, this can be even replaced as if you are using x of 0 into del of t, also we'll get the value as x of 0 because we are multiplying only the 0th value. Now, convolution property. Now, this is the normal convolution integral. That is, this is a formula. That is x of t is equal to integral minus infinity to infinity x of del x of tau del of t minus tau d tau. Normally, this is used as a convolution property. Now we are going to see all those properties in discrete also. Now the properties of discrete time unit impulse function. Now del of n is equal to u of n minus u of n minus 1. Now we'll use u of n. U of n is a next unit step signal we are going to study in the next slide. But still u of n means it will be a step signal. Step signal in the sense it will be equal to 1 for t greater than or equal to 0. That is u of n. Now u of n minus 1 means u of n minus 1 in the sense delayed by a function. That is 1. That is from 1 to infinity the value will be, that is 0 to infinity, this is 1 to infinity. Now subtracting these two will get the value as, as del of n. Del of n means it will be equal to 1 for t equal to 0. We have to put it a dot because it is a discrete function. Now, del of n minus k, the similar thing we have seen there, it is shifted. Now it will be equal to 1 for n equal to k. Whenever n equal to k, we'll get the value amplitude as 1 or else it will be equal to 0. Now same thing, a convolution property here also, x of n is equal to summation n is equal to minus infinity to plus infinity to x of k del of n minus k. Now, this also we have seen there. X of n by shifted by a value of n minus n0 will get the value of x of n0. Now, these are the properties of discrete time unit impulse function. Thank you.